Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, dear students. Today, inshallah, we are going to answer some classified questions about topic 1, lesson 2, motion. And firstly, look at these questions and try to answer them before I answer them with you. These are the questions. Let's start. The first question is about a graph. In this graph, we have an object. A car is moving for 5-second period. And we are asked to get the correct answer from these rows. Okay. Firstly, look at the graph and what is on y-axis. Again, it is the speed. What happens to the speed here? It starts from 0. This means the object was at rest here when the time is 0. And the speed increases with time. This means we have here acceleration, or the object is accelerating. And here the speed remains constant here. So we have here a constant speed. This means the acceleration equals 0. Good. Look at this. The car is at rest at what time? As we said, at 0. So it is A or B. Good. At what time the car is moving at a constant speed? It was moving at a constant speed from 3 to 5. So the answer is 4. This means the correct answer is B. Let's move to another question here. Which row defines the speed and velocity? The speed, the distance traveled per unit time, it is B or D. Good. What about the velocity? The velocity is the speed in a given direction. We have here B or C. So the correct answer here is B. Look at this one. We have here a graph, and what again is on y-axis? It is the speed. So we are here describing what happens to the speed as time changes. In A, the speed is constant. In B, the object is decelerating. In C, it is touching the time axis. This means the speed is 0. In D, the object is accelerating. The question here is, which section of the graph shows the time when the motorcyclist is stationary at some traffic lights? Stationary means at rest, and at rest means V equals 0. So the correct answer is exactly C. About this one, this is the easiest one here. We have here the diagram, and this solid object is affected by two forces. A force of 4 newtons to the right and another one of 3 newtons to the left. So this one, what is the resultant force here? The force is a vector, so if we consider a direction positive, the opposite direction is negative, so we subtract them. So the resultant force equals 4 plus -3. This means it is 1 newton. It is positive here, and 4 is positive, so it is in the direction of 4, so it is to the right. So it is 1 newton to the right. A student measures the average speed of a cyclist in a race. Which quantities must she measure? What is she measuring? The average speed. The average speed equals total distance over total time taken to cover this distance. So if we have a distance, we have the time to cover this distance. Good. They said here the total time. It's good. Beginning taken to complete the race and the time. No, we have here two times. We don't have here the distance. We must have both of these. The total time taken to complete the race, it's okay. And the total distance traveled by the cyclist at her highest speed. No, we need the total distance at all. Okay, the total time taken to complete the race, yes, it's okay. And the total distance traveled by the cyclist. Yes, but let's have a look on D. The time taken to reach the highest speed, no. So the answer is C. Look at this one. The speed time graph represents a short journey. Which distance time graph represents the same journey? Look at this. Again, the speed here. What happens to the speed? The speed is increasing. This means the object is accelerating. We have here distance time graph. Distance time graph. Which one represents an accelerating object? Look at C and D. The C, the distance doesn't change, so the object is at rest here. At D, we have the same shape, but this is distance. The distance here changes regularly. This means we have here a constant speed. We still have A and B. Look at this one. If we have distance time graph, the steeper the graph is, the faster the object. For example here, this one is steep, or this part is steeper. This means in this part, the speed is higher than in this part. For example, in part 1 here, the speed is higher than in part 2. This means the object is slowing down. This means the object is decelerating, but this graph accelerating. Look at B. Here, this one is or less steep than this one. This means what? This means that the speed here in 1 is less than in 2. This means the object is accelerating. So in B, it is the correct answer. An object falls towards the surface of Earth. The object is falling at its terminal velocity. Which statement is correct? Terminal velocity means constant speed. This means the acceleration is 0 because the weight of the object equals the air resistance. And the object reaches terminal velocity if we have air resistance. So there is air resistance, yes. There is air resistance in A, it's okay. Air resistance in B, it is okay. No air resistance in C and D. Look at A and B. They said that there is air resistance and the acceleration of the object is negative. No, we don't have any acceleration. B, there is air resistance and the acceleration of the object is 0. Yes, because the object is moving at a constant speed. So the answer is B. Look at this one. What is the distance? We have a speed time graph. The distance equals speed multiplied by time. From this triangle, you remember, speed equals distance over time. This means distance equals speed multiplied by time. Good. The speed is on y-axis and the time is on x-axis. Good. So the distance here equals y multiplied by x. This means it equals the area under the graph. What is the area under the graph? It is this shape. This is a triangle here. What is the area of the triangle? Equals half base times height. So it equals half times 400 times, this is the base 400, and the height is 20 times 20 equals half times 20 is 10 times 400 is 4,000. So it is 4,000. It is here meter per second and in second. So it is meter per second multiplied by second. This means it is 4,000 meters. Another question about the distance, because they said here how far. The graph represents the motion of a car, and how far means we are calculating the distance. No need to read it because I have already read it. How far has the car moved between 0 and 5 seconds? Look at this. We have here the area under the graph. Why? Because we have here speed and the time. As long as we have speed and time, or the speed time graph, and we want to get the area, this means, sorry, we want to get the distance. This means we are getting the area under the graph. It is a triangle, so the area equals half times the base, which is 5, times the height, which is 10. So the answer is 25 meters, because it's here meter per second and the time is in seconds, so the distance is in meters. Look at this one. Okay, read it well. And please look at this point and this point. Of course, at this one. What is the initial acceleration? In the beginning, it is moving at the acceleration of free fall. Good. But they said here, eventually, finally, it reaches terminal velocity. This means what? This means the acceleration equals 0. So the terminal velocity, the final acceleration equals 0. Okay, so it is A or C, but we choose before here C, so it is C. The same thing here. We have here a graph shows a motion of a sprinter. This is a sprinter. She accelerates from 0 to 8 meters per second. How far does she travel in the last 3 seconds? During the last 3 seconds. Where are the last 3 seconds? They are from 4. This is 1, 2, 3. 1 second, 2 seconds, 3 seconds. So from this point to this point, we want to get what? How far? This means the area under the graph because how far means the distance, so we want to get the area under the graph in the last 3 seconds. What is the area here? The area here is the area of a rectangle. It equals length times width equals the length is 3 seconds times the width, which is 8 meter per second. So the answer is 24. We have here meter per second and we have here second. This means it's 24. So the answer is D. Good. Let's have another question here. In which part of the car is decelerating? Decelerating, this means the speed decreases. Okay, we have here speed time graph. So the line which is going down, this means it's decelerating. Good. What about this question? It reaches terminal velocity. This means its speed here is constant. Good. After being dropped and falling through air. This means we have air resistance. Good. All of them reach terminal velocity. This part is correct. This part is correct. This part is correct. And this part is also correct. But look at this. Look at A. We have here a straight line. This means we have here a constant acceleration. So this one is not correct. Look at B. In B, it starts with a low acceleration, and after that the acceleration increases because we are talking about a speed time graph. This is the acceleration here. This is the acceleration here. So it starts with a lower acceleration and its acceleration increases. Through air, the opposite happens. In air, it starts with a higher acceleration and this acceleration decreases because of air resistance. So this one is not correct. Look at C. This is also speed time graph. This means the speed increases at a high acceleration, and after that this acceleration decreases. Yes, this is what happens when an object falls in air. It starts with a high acceleration, and after that the acceleration decreases because of air resistance till it reaches a terminal velocity. This is correct. What about this? This can never happen because the speed doesn't decrease when the object falls in air in the beginning. So the answer is C. Look at this question. A car accelerates uniformly in a straight line from rest at time t0. At time equals 3.2 seconds, the speed reaches 13 meters per second. Calculate the acceleration. The acceleration equals a change in velocity over time. The change in velocity means what? The final velocity minus the initial velocity over the time. Good. The final velocity here, what is the final velocity? When the speed reaches after time, this is the final velocity. It's 13. Minus the initial velocity, they said that starts from rest. This means at time equals 0, the velocity was also 0 over when the velocity is 13.0, the time was 3.2 minus when the speed is 0, the time was also 0. So the acceleration equals 13 over 3.2. 13 over 3.2 equals 4.0625. This means the acceleration equals 4.1 for two significant figures, 4.1 meter per second squared. Explain in words what is meant by the acceleration. As you know, the acceleration is the rate at which the velocity changes. Okay, or you can say that it is the change in velocity per unit time. Look at this one. In figure, we have a parachutist. A parachutist who jumps from a stationary hot air balloon. Look at this. The parachutist jumps from the balloon at time 0. It's okay. This is a speed time graph. And reaches the ground at B. Yeah, good. The point A indicates when the parachute opens. At this point, the parachute opens. On this figure, label point on the graph when the acceleration is 0. What is this again? This the speed. Acceleration is 0. This means constant speed. Okay. And constant speed means terminal velocity here. And we have here two terminal velocities. This one and this one. So we can put here 1 and 1 here. This is correct, and this part is also correct. Good. Negative acceleration. Negative acceleration means the speed decreases. It is decelerating. And the only part in which the parachutist is decelerating is in this part. So we can label this too. Good. Decreasing. The acceleration is decreasing. The acceleration decreases, okay, when the gradient of the graph decreases, and it decreases at this curve. This means we can label this 3. Okay? Okay. Look here. This graph, we want to determine the distance traveled by the cyclist between time 0 and 100 seconds. And please pay attention here. What I heard you said that we will get the area under the graph. I'm sorry, it is not correct. Why? What is on y-axis? Exactly, it is distance. So it is very simple. We go to the 100 seconds and see the distance here. The distance is 400 meters. Very simple. No more. Because we have already distance on y-axis. So the distance covered between 0 and 100 is 400 meters. Calculate the speed from the graph. These questions are about the graph. Calculate the speed of the cyclist between time 0 and time 100 seconds. This is the speed, this is distance time graph. If we want to get the speed, this means we are getting the gradient. Okay, the gradient equals rise over run. This is the rise. Over the run. Okay, the rise is from 0 to 400, so it is 400 minus 0 over the run. What is the time at 100, at 400? It is 100. And what's the time for the speed, for the distance equals 0? It is also 0. So it is 400 over 100, which equals 4 meter per second, because the distance is in meters and the time is in seconds. So the speed equals 4 meter per second. Describe the motion of the cyclist between time equals 100 seconds and 250 seconds from the graph. 100 seconds to 250 seconds. From 100 to 150, the distance can never decrease. So it is, the object here is at rest, or the cyclist is at rest here. So you can say that between 100 seconds and 150 seconds, the cyclist was stationary. From 150 seconds to 250 seconds, the cyclist was moving at a constant speed. So you can see here, why constant speed? Because I have here distance time graph and we have a straight line. The gradient is the same for every point on this line. So we have here a constant speed. Okay, we have here a constant speed. No need to get the value of this speed. No need to get the value of this speed because they said only describe the motion. Describe the motion. We don't need to mention the value of the speed or the magnitude of the speed. Define the acceleration. We said once that is the rate at which the velocity changes. Show that the maximum speed of the train is approximately 56 meter per second. The maximum speed, they said, they said here the maximum speed is 200 kilometer per hour. 200 kilometer per hour, does it equal to 56 meter per second? We will show this. We have to show this because they said show that. Look at this. How to convert from 200 kilometer per hour to meter per second? Very simple. It is 200 kilometer per hour. It equals 200 kilometer over hour. And we want to convert it to meter over second, meter per second, equals 200 times kilometer. This means 1,000 meters over hour equals 60 minutes times 60 seconds. After calculating this, it gives about 56 meter per second. Okay. Calculate the time taken for the train to reach its maximum speed. I think it's very easy. Look at this. We have here acceleration equals the change in velocity or the change in the speed over the time. From this, the time equals the change in the speed divided by the acceleration. So it's very simple. The change in the speed, k equals the final minus the initial velocity over the acceleration here. The final velocity, maximum velocity or maximum speed is 56 meter per second over. Why did I choose this meter per second and I didn't choose kilometer per hour? Because the acceleration is in meter per second squared. So the speed must be in meter per second because the acceleration is in meter per second squared. Minus, this is the final or maximum speed, minus the initial speed. They said here from rest. So the initial speed is 0 over the acceleration, which is 0.7. So the time taken by the train to reach its maximum speed is 80 seconds. This is the end of our lesson, and I hope you understood everything. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.